This is your last video for week 4, task 2. This is page 2 over exponential decay. So the first video covers growth. This one we're doing decay. So exponential decay occurs when a quantity decreases by the same factor over intervals of time. So if you notice, this formula looks very different. The main difference is a subtraction sign instead of an addition sign. So both of these formulas, we start with 1 and we either add a rate to it or we subtract a rate to it based on if it is increasing or decreasing. So for example 3, the NCAA basketball championships, also known as March Madness teams, play against each other, with only the winning teams progressing to the next round. In other words, after each round, half the teams are eliminated. If a play begins with 64 teams, write a function that represents the number of teams. So we start with 64. And then we have 1 minus 1/2. That's what it said. Half of the teams are eliminated. So you lose half each time. And that is raised to the x. Okay? Now again, we can simplify this. 1 minus 1/2 is 1/2. Or you can put 0.5 if you want as well. Then they want to know how many teams remain after 4 rounds. So in my calculator, 64 times 1/2 raised to the 4th. There would be 4 teams remaining, okay? And then sketch a graph. So we would start at about 64. After 4 rounds, we have 4 people. So we can see this is going to decrease really quickly. Example 5, certain things that you buy in real life lose their value. A car is one example. There's a saying that your car is never as valuable as it is as the second you drive it off the lot, okay? As soon as you buy a car, when it goes, like when you take it away, it no longer has the same value, which is crazy because you could drive it around the block, change your mind, and bring it back, and suddenly when you try to sell it, it's not worth as much as when you bought it. But that's just the way the world is. So, value of a car starts at $35,000. It depreciates, so it loses value. Depreciates, losing value. So we're taking it away. 10% in value each year. So first write that function. So 35,000 times 1 minus 0.10 raised to the x. So 35,000, 1 minus 0.10 raised to the x. What will be the value in 10 years? So we're going to replace x with 10. So 35,000, 1 minus 0.1 raised to the 10. So, wow, in 10 years, it's only worth 12,000 now. 12,203.75. So 12,203.75. Okay? And then when will the value be less than 10,000? So again, we're going to put that equation into y equals and search for this in the table. So in y equals, I'll just clear that, 35,000, 1 minus 0.1 raised to the x, go to that table. So I'm going to scroll. Remember, for some reason, mine's glitchy. So I'm looking for where this is less than 10,000. So at 11, it's at 10,900. I want less than 10. So that would be 12 years. So in 12 years, which makes sense because 10 years was kind of close right here. So after 12 years, it is less than 10,000.